Hello students. In the last class, we have seen temperature sensors. Now we will discuss pressure sensors. These pressure sensors are very simple in construction. So these are the topics we have seen. Now we will complete pressure sensors. So this is the we are here now. Pressure is the force per unit area that a liquid or gas exerts on its surroundings. Its units, it is expressed in pounds per square inch psi or pounds per square foot psf, or in English units pascals, in metric units which is force newtons per square meter. So formal definitions: absolute pressure is used for pressure measured relative to vacuum. Differential pressure is the difference between two pressures is measured. Gauge pressure of the pressure measured relative to some fixed pressure, usually atmospheric pressure. So this is how you can see this is vacuum pressure and absolute pressure, and the total is atmospheric pressure. This is the reference pressure, and this is gauge pressure. And absolute pressure. Absolute pressure is from vac- vacuum pressure up to from vacuum pressure it is measured, and the total pressure will become absolute pressure. So this relation, with this relation we can calculate all the forms of pressures. Instruments for measurement: gravitation type manometers, mechanical displacement type ring balance manometer, bell type manometer, elastic pressure transducer, Bourdon tube pressure gauge, diaphragm type gauge, bellow gauges, electrical pressure transducers, resistance type pressure transducer, potentiometer devices, inductive type transducer, capacitive type transducer, piezoelectric pressure transducer, Bridgman gauge, low pressure measurement gauges such as McLeod gauge, thermal conductivity gauge, ionization gauge, varying pressure measurements such as engine indicator, CRO. So working principle here, the elastic deformation only. Force summing devices which convert the applied pressure to displacements, and primary transducers, while generated displacements may be measured by secondary transducers. The commonly used force summing devices are diaphragms, bellows, and Bourdon tubes. So retrofitting any of the devices like LVDT or some other device, we can use diaphragms and bellows. Strain gauges also we can retrofit with this to measure pressure. Diaphragm sensor: the movement of the center of the circular diaphragm as a result of pressure difference between its two sides is the basis of pressure gauge. For measurement of absolute pressure, the opposite side of the diaphragm should be vacuum. For the measurement of pressure difference, the pressures are connected to each other of the diaphragm. For gauge pressure, the pressure relative to the atmospheric pressure, and the opposite side of the diaphragm is open to atmosphere. So this is how you can measure the different types of pressures using diaphragm sensor. So this is the diaphragm sensor, and the diaphragm deflects because pressure greater on other side than this side. So here this is the conjugate type, and this is the diaphragm where the deformation takes place like this. So diaphragms of different kinds. This is evacuated chamber, and this is diaphragm. Pressure is applied here, and you can attach a strain gauge, or you can attach a LVDT here. The deformation can be measured. That is directly proportional to the pressure applied here. And this is the differential pressure measurement, and conjugated diaphragm in capsule form. It is in capsule format. The movement of the center of diaphragm can be monitored can be monitored by some form of displacement sensor. Here, this is the figure that shows form that might be taken when strain gauges are used to monitor the displacement. These strain gauges being stuck to the diaphragm and changing resistance as a result of the diaphragm movement. Typically, such sensors are used for pressures over the range 100 kilopascal to 100 megapascal with an accuracy up to plus or minus zero point 0.1 percentage. So bellows also very much like diaphragms. These also elastic members. Bellows are thin-walled cylindrical shells with deep convolutions and are sealed in one end. At one end, the sealed end suffers axial displacement when pressure is applied at the top end. So LVDT as a secondary transducer in conjunction with bellows. So you can retrofit it and you can measure the displacement. So that is directly proportional to pressure applied here. And piezoelectric sensor, when certain crystals are stretched or compressed, charges appear on their surfaces. This effect is called piezoelectricity. Examples of such crystals are quartz, tourmaline, and zirconite titanate. The piezoelectric pressure gauge consists essentially a diaphragm which passes against a piezoelectric crystal. Movement of the diaphragm causes the crystal to be compressed and so charges produced on its surface. So it is a crystal. Crystal can be considered to be a capacitor which becomes charged as a result of the diaphragm movement, and so potential difference appears across it. So here this is a active type transducer or sensor. So piezoelectric sensor, the amount of charge EMF produced and hence the potential difference depends on the extent to which the crystal is compressed along the specific axis, and hence is a measure of the displacement of the diaphragm, and so the pressure difference between the two sides of the diaphragm. If the pressure keeps the diaphragm at a particular displacement, the result electrical charge is not maintained but leaks away. Thus, the sensor is not suitable for static pressure measurements, and that is the drawback with this type of sensor. Piezoelectric sensor, the quartz, lead zirconate, and barium titanate, and here this is the crystal. And the diaphragm here you have diaphragm, and there you can retrofit this crystal, and you can get the potential difference as the result of pressure. So these are the books you can rely on, and there ends this topic, and we will see in next topic, students. Thank you. We stop here. Thank you. Thank you, students.